In this video, we're going to take a look at some application problems which require trigonometry to solve them. The first one we're going to take a look at is a related rates problem. So a lighthouse L is located on a small island 2 kilometers from the nearest point A on a long straight shoreline. If the lighthouse lamp rotates at 3 revolutions per minute, how fast is the illuminated spot P on the shoreline moving along the shoreline when it is 4 kilometers from A? All right, so we should definitely draw a picture. So here we have a shoreline, and we'll call this point A, and this will be P. Now it does say that the distance from P to A is 4 kilometers. However, we know that this distance P is moving, so we're going to call this X because we don't want it to be fixed. Now there's a lighthouse L. It's located on a small island 2 kilometers from the nearest point A. So that means if I place my lighthouse L, that would be the closest point to A here. All right, so this is on an island of its own. So the lighthouse lamp rotates at 3 revolutions per minute. So we want to find out how fast is this point P moving. All right, so we're going to connect this distance from L to P as well. Now the distance from L to A is fixed, so I'm going to call that 2 because it says 2 kilometers. And let's say that this is an angle of theta. So we're going to say let theta equal the angle between the shortest distance and distance to P on the shoreline. We also have X, and X is the distance from A to P, and that's moving. All right, now the other information that we're given is that the lighthouse is rotating at 3 revolutions per minute. So this is why we need the theta. So d theta dt is equal to 3 revolutions per minute. Now we want to change this so that we have some kind of measurement that is in radians. So we're going to multiply this by 2 pi, and this will be 2 pi radians per revolution. So that means in one full circle, it rotates an angle of 2 pi. So when we multiply this, our revolutions will cross off. So now we have 6 pi radians per minute. Okay, so what are we trying to find? So it says, if the lighthouse rotates, blah, 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 how fast is the illuminated spot? So how fast is the illuminated spot on the shoreline moving? So that is the distance, x, and the rate of x. So we want to find dx dt. Now, if x is 4, we know that h squared, so we'll call this the hypotenuse here, is equal to 2 squared plus 4 squared. So h squared is 20, h is root 20, and you will see why I'm not going to simplify the radical. And then we are going to now find a relationship between theta, x, and 2. So we could use the hypotenuse as well, but we already know that theta is, we have a relationship here. So we can say that tan theta is equal to x divided by 2. We also have x is equal to 2 times tan theta. So taking the derivative of both sides, we have dx dt is equal to 2 times secant squared theta d theta dt. So dx dt is equal to 2. Now secant theta, we don't actually need to find theta from here. We could find theta and then plug it into theta into the expression here and then take the secant of that. But however, we also can just find secant theta from the triangle. So if we take secant theta, we know that secant is the reciprocal of cosine. So that will be 2 over h. So secant will be h over 2. And over here, remember that I found what h was. So therefore, h is going to be root 20 divided by 2. And this will all be squared. And then we also have d theta dt, which is 6 times pi. So multiplying all of this out, so you can see that when I take the root 20 and then I square that, I'm actually going to just get 20. So that's why I didn't need to actually find the number here. So I have 20, and then we have divided by 2. So 20 divided by 2 is going to be 10, because one side is 4. And then we have times it by 6. So we actually end up with 60 pi, which is approximately 188.496 kilometers per minute. All right, let's take a look at a different question. So let's take a look at one where we have to find the maximum and minimum. So in this question here, find the first derivative, set it equal to 0, same as before, and solve for x. And then use these values of x to determine if f prime is positive or negative, so that we can find our local or absolute max and min. So here it's asking us to classify all the local extreme values of f of x equals x plus sine x. So f of x is equal to x plus sine x. So we need to find the first derivative. So we get 1 plus cos x. Set this equal to 0. So we have cos x equals negative 1. And then from our graph, we know that happens here at pi. But if we go backwards, we also know that it happens also, at negative pi. So we can go plus or minus pi, and then the next one will be plus or minus 3 pi, and so on. So generally speaking, we can say that it's going to be pi plus 2n pi, where n is an integer. All right, so what we're going to do now is to draw our number line. And then we're going to plug in values into in between negative pi, and so on. So for example, let's say we plug in 0, and when we plug in 0 into our question here, we have cos 0, which is 1, and then 1 plus 1, we get 2. So that's going to be positive. Same thing, the next one we're going to plug in is 2 pi. So when we plug in 2 pi, we see that again it is 1, and 1 plus 1 again is positive. And if we actually keep doing this, knowing that cosine is periodic, we can see that this will always be positive. So therefore, actually, this question here, or this function, there is no absolute max or minimum value, since the graph keeps on increasing when we are looking for any maximums. All right, now the last one that I wanted to take a look at is, which is actually one of my favorite type of problems, is the optimization problems. So find the length of the shortest ladder that can extend from a vertical wall over a fence 2 meters high, which is located 1 meter away from the wall, to a point on the ground outside the fence. All right, how does this work? Okay, so we have this wall here. Okay, and we want to find this ladder that can extend from this wall that's over a 2 meter fence. So the fence will be right here. Okay, and this fence is going to be 2 meters. All right, now what we want to do is we want to find this ladder that can extend over the wall, that extend from the wall over the fence, and 2 meters high, is located 1 meter away. So this distance here, from here to here, is 1 meter. so that it falls to a point on the ground outside the fence. So this often happens, right? You want to find that ladder that we can go across here like this. Okay, so we're going to say this is an angle here. So theta is the angle of inclination of the ladder. And obviously for safety, that angle has to be between 0 and pi over 2. And let's say that we have this ladder and it's going to be a L. Okay. Now the whole ladder will be from here to the bottom here. However, to make it easier for us, we should split this up into two parts. So I'm going to call this y and this part x. So therefore, we have that L is equal to x plus y. All right, so now how can we create any information here? So we also know that we're going to plot this to be 1. And this also has to be theta, because these are corresponding angles, because we're going to make these two lines parallel. So one of the things we can do is we can say that sine theta, based on the bottom small triangle down here, is equal to 2 divided by x. So therefore, x is equal to 2 over sine theta. Using this upper triangle up here, where y, theta, and 1, we have cos theta is equal to 1 divided by y. So therefore, y is equal to 1 divided by cos theta. All right, so plugging these two expressions in for my x and y here, I have L is equal to 2 divided by sine theta plus 1 divided by cos theta. All right, so now let's take the derivative. So L prime is equal to negative 2 times sine squared theta. And then, so using the reciprocal rule, we have the negative 2 and the sine squared theta. But remember, now we also need to take the derivative of sine theta, which is cos theta. And then we are going to now go 1 over cos, so take the reciprocal of that. So it's going to be negative 1 over cos squared theta. And the derivative of cos theta is negative sine theta. All right, so actually let's write that L prime is with respect to theta. So now let's simplify this a little bit. We have negative 2 cos theta over sine squared theta plus sine theta over cos squared theta. Okay, so we need to move over to here. So moving this so that we get a positive, we get 2 cos theta over sine squared theta equals sine theta over cos theta. Doesn't look like we can do much, but look, I'm going to manipulate this. I'm going to move my cos and sine squared from the left side by multiplying by sine squared over cos theta. So I'm going to do it to both sides. So now I get sine cube theta over cos cube theta, which is, using my trig identity, is going to be tan cube theta. So, running out of space here. So I'm going to cube root both sides. So now I have the cube root of 2 is equal to tan theta. So then theta is equal to the inverse tan of the cube root of 2. So now that we know what this is, I can now actually plug this value in. I'm going to plug this in all the way back to theta here and here, where L is equal to this expression. So when I plug that in, so I'm going to get L is equal to 2 divided by sine inverse tan of cube root 2 plus 1 over cos inverse tan of cube root 2. And when I plug that in, I will get 4.162 meters, which you can try and plug in yourself, and you should try to do that yourself too.